coming, so we've seen this video quite a few times, but for the ones that is your first time, I hope you enjoyed knowing a little bit more about KWAN. Thank you for being here again. So, I'm Lucia, I'm part of marketing of KWAN. We are here every month doing meetups or webinars, so you're very welcome to come back again, either presentially like we are now, and also online. So follow us on social to know our events. We have many events. We accept your suggestions, so if you have like teams you would like to see here, we're very happy to bring them to you. As you know, this is co-organized KWAN and Ironhack. So next I'm gonna call Cynthia. Just one more information that I forgot. Miguel here is from our department of recruitment. So if you have any questions about open positions at KWAN, talk with him during the coffee breaks. We have 2 coffee breaks, so we're gonna start in one talk, then we do a coffee break, then we come back for a second talk, and then we have more time to network and get to know each other. Okay? So now I'm gonna give the words, I don't know if you say it in English, to Cynthia.
Thank you.
Give you the stage.
Hi guys, welcome. I'm very glad that you're here, and I hope that you enjoy this event with these awesome speakers that we have today, who I thank as well. So I'm Cynthia, and I work in Ironhack in the marketing team, as well as Leonor over there. And we have here with us also Carolina from the career advisory team. So Ironhack is a tech school. For those who don't know, we have several boot camps, and we are very beginner friendly, so everyone can join, even though if they didn't have a career in tech before, or if they have previous careers in other areas. We do several boot camps, especially those that are here in the roll-up, which is web development, UX, UI design, data analytics, and cybersecurity. Those are the ones that we do since 2013. And now we have several new boot camps that have started this year, especially machine learning and data science, that we have here the teacher, João, who will talk more about this later, but also AI engineering and DevOps and cloud computing. So we are promoting these boot camps, and we also have the options for you to do it full-time or part-time. So if you want to know more about this, we can also talk in the coffee breaks, but for now I would give the word to João, who will talk a bit about the course, but of course about the subject that you all came here to talk about. Before we start with the talk, I'd like to ask you, like, what is your tech knowledge? So are you beginner, are you more intermediate, are you more advanced? So as we are a few here, so we can discuss like very briefly. So who is a beginner? Okay. Who is like intermediate? Okay. And more advanced, who knows a lot about tech and machine learning especially? Great. Okay. So we'll have with João a more introductory talk, and then we have with Fernando a more specialized talk. So I hope you guys enjoy it, and João, the floor is yours. Thank you.
Great. So, hello everyone. Yes. So thank you, Cynthia. Yes. So just before I start, a brief introduction to what Cynthia said. Right now I'm teaching the data science and machine learning bootcamp. It's 9 weeks, where we actually start from the very beginning. For those who are a little bit more advanced, our first lesson is about lists and functions and objects, and all the way up to actually implementing machine learning models. And right now, of course, a little bit of Gen AI, because the material's got to be adapted. And today, what the challenge that here between Ironhack and KWAN we were introduced is to talk to you a little bit about how all this works when it comes to internal knowledge, right? So we've all been, I hope we've all heard about ChatGPT, we've all tried it a bit, hopefully you even tried a couple of alternative tools like Claude and Gemini, and you know that it's not just the one thing there, but one thing that is being a great conversation at corporate level. So inside the company is, okay, great, ChatGPT knows who was the king of Spain in the 1500s. But how can ChatGPT know the name of my particular project, the internal tool that's being built in my consulting company of IT? So how are we going to start mingling these two things? And that's exactly the concept that I will bring today, is that we always need to think that these models, these tools were trained with two types of data, let's call it like this. So, on one hand, we need them to know general things, right? We need them to know how to think, how to understand the language. We need them to know terminologies, right? When I ask someone, what time is it? I don't want to explain them what a watch is it, or what time is it, or that time breaks down in 24 hours, right? We want them to know general things, and then we have the other section of this internal information that LLMs can have, which is, okay, now I want you to know the particularity, right? Now I want you to know if I want a ChatGPT for my internal projects, it needs to know information about those projects. How are we going to have these two? Because what is the challenge here? On one hand, the entities in the world big enough to do this part cannot do this one, right? So they cannot be focused. Google cannot be focused on, with all due respect, on KWAN's internal tool. And KWAN doesn't have the manpower to do this part. So that's exactly where everything gets tricky. So let's see an example here. If I ask, who is the king of Spain? What we're actually doing here is this, right? So, the expression who is, knowing the pronoun of addressing to a person, knowing what a king means and knowing what Spain means, it's something I expect the model to have. Knowing who is the king of Spain is particular information that it has to get somewhere. And that somewhere is the trick here. Right now, there are three ways for us to input, let's say like this, for us to input information inside one of these models. Sorry, hands up, LLM, large language model. Okay? It's what ChatGPT is, for those who didn't know. And so, as I was saying, we need three particular ways, we have three particular ways to inject information inside a model. Let's call it like this. The first one is its initial training. So when we start the model, let's call it like this, when we create the model, that's where 98% of the information comes from. So when we start the model, we start by training the model. Okay? I'm sure even if those who are not experts in the field, I'm sure you've heard the expression to train. Right? Models are trained in data. As a variation of this training, it's now being called fine-tuned. Fine-tune means I take a model who was previously trained and I add a little bit more, let's say. I fine-tune it, hence the name. I make some changes on the model's internal parameters so that it now answers with new information, okay? And the last one is in the prompt itself. The prompt is the text we give the model to get an answer back, okay? And this last one is where we have a lot to talk about. Covering first the first two. What are the pros and cons and what are the tricky parts about it? So one thing here, they are insanely important and maybe even the future of the industry. But the truth is that they are fixed parameters. Okay, we can fine-tune a model, but on a daily basis, they are fixed parameters. It's something that we provided the information, but now it is what it is. Right? I can't change this in real time. It's not realistic to change this in real time. Here are a couple of examples of the pros and cons. Okay? We do it because they would be better models. Okay? There is a better accuracy to it, because this way we can give them slightly smaller prompts. They end up being cheaper to ask questions. Okay? So there are a lot of reasons to do it. What are the cons that you might not know? So first, the tech part itself. There's a tech part involved to actually fine-tune or train a model, right? They cannot forget information. Okay, this is a particularity of fine-tuning a model, a little bit like the human brain, right? Once you give it information, the only thing you can do is tell it the information is not valid anymore, right? But you're actually giving them two pieces of information. You can't really go into the model like a little box and delete a file and say, okay, now forget this, it's outdated, forget this. So this doesn't happen. And because of all of this, all the data collection and the data processing and this and all we've been saying becomes a little bit hard to do at a real time, and a day-to-day, let's say like this, in a day-to-day situation, which is what we want, right? We want a tool that looks at our Google Drive or OneDrive or intranet or whatever it's called in the companies you guys work at, and which is constantly changing, because today there's a new project, yesterday's project was deleted, the project is delayed, so now the delivery date is not the original one, so everything it's constantly changing, and I need some kind of engine, some kind of agent that I can chat with it and collect the information of this source of information that we all already have, our emails even, our meetings, all this. And the solution for that, and the future of the industry in this section, let's say, the way I see it, is through the prompt. Is through changing a little bit the status quo, changing the mindset into which we ask questions, like we see here in this example. Imagine that one day you actually have a system where instead of you asking who is the King of Spain, you don't really care if the engine knows who's the King of Spain. Because what you're going to tell it is, here's a history book. Based on this history book, who is the King of Spain? Right? This is what happens inside your company is, here's all the documentation of my project. I don't care if you know what Project Lighthouse of the internal agile tool of Ironhack is. We know the system doesn't know it, right? I don't care that you don't know it. I want you to answer me, is there any issue with the delivery date of the Lighthouse project based on this documentation, okay? And this is what's happening, and it's happening already. I'll explain to you in a bit how these systems work. But this is what's already happening in a system where we are working through the prompt. And the advantages are that the fact is real-time information can be used, because now we've completely separated systems, right? We can provide information at the same time as we are asking the question, okay? And of course, one very, in my opinion, almost a funny story that I'll tell you in a bit, is that as models evolve, we can use the best model that just came out of the market, right? Versus if we focus on fine-tuning and training a model, now we're stuck with that version of the model. Suddenly a new model came out and now we have to fine-tune it again, okay? So there's a lot to come to. What are the cons? It's not just good things. What are the bad things about it? It becomes more expensive and less accurate, because as you can imagine, and this happens to the same thing as humans, if I ask you who is the King of Spain, I'm asking you 10 words, right? If I ask you, hey, here's a history book, who is the King of Spain? Now you need to read the whole history book and find out who's the King of Spain. So this makes it a little bit less performance. And then the last one I added in honor of our next speaker, which is the quality of this is hard to measure. That's what Fernando will talk about in a bit, so I'll leave it at that. And as I was saying, let me tell you a funny story that happened to Bloomberg, which an official source, they spent around $10 million. It's not impossible, so I didn't find an official source, but I believe it. Bloomberg spent around $10 million fine-tuning, so preparing the GPT 3.5 version to be an expert in finance. And what happened was, it took them a certain amount of months and $10 million. By the time they were ready, GPT-4, the version after, had come out, and it was actually better at finance than the adapted version of GPT 3.5. Okay, so this is the reason why, besides a couple of big players, and there's still many, but a couple of big players throughout the world, or a couple of very specific use cases, that can happen as well. If we want a system that is changing in real time because our internal information is in real time, we need to work in this kind of mindset of, based on this document, who is the King of Spain? Okay? Which leads me to the million-dollar question. Imagine that you do this with your internet, right? We're talking about thousands and thousands of pages of PDFs. You can ask, based on this history book, who is the King of Spain? But the problem now is, which history book? Right? Because for the question, who is the King of Spain, it should be one book. It should be one set of pages of PDFs. For the question, when is the project Lighthouse going to end? You need another set of pages, right? So the problem now becomes, you've split the problem into several pieces, but you've added an extra piece, which is, when I ask the question, how do I know in which information I need to look for? Right? How do I find the relevant information to answer that question? Because if every time I ask a question, the system needs to read the entire internet, then we're back to the same problem, right? So we need to find, okay, you ask the question, and that question, I bet it's answered in these 10, 12, 15, 13, 40 PDFs, okay? And that's exactly what I'm going to talk to you about today, and hence the name of that's the term that was created, Retrieval-Augmented Generation. Because it means I'm doing a generation, right? I'm generating an answer which was augmented, so it was improved by a certain retrieval process. Okay? What's a retrieval process? It's the concept of taking documents. By the end you'll understand all the pieces, don't worry. Right now, let's think of it high level. It's taking documents and you put them all in a database. Okay? As you get a question, you check the database and you bring with you the most relevant ones. Okay, so there's a match, which I'll explain how it's done in a bit. There's a match between your question and the documents that might have the answer for you. Okay? Think of it, the simplest way I could explain is, think of it like a Google search, right? You searched on Google, but instead of getting the answer straight from Google, you are now going to provide the first 100 links to ChatGPT. And based on those 100 links, which are filled with 99% of useless information, right? But the 1% is found by ChatGPT, by the LLM, and is able to answer the question, okay? This is done through a process called embeddings, which I'll go through just high level. There's whole PhDs on this, so just high level so that you understand. To embed something is the way we found for computers to transform words into numbers, which is important for computers to understand their meaning. Because, for example, if I don't transform words into numbers, if I simply match words based on their letters, this could happen to me. Like, I know I have documents with the words lab, student, and exercise, but the question was, someone in my class had a question. All of us here know these two things are connected, right? But there isn't a single word that is common. So for that, what actually ends up happening is the computer has the ability to interpret the concept of a word, okay? Not their letters, but the idea behind the word. And because of that idea, it's actually also able to understand if two ideas are close together or further apart, right? And this technique allowed us to create a retrieval process. Why? Because then, based on the question, I can understand which terms are connected to my question or not. And hence, that will allow me to retrieve the documents that are close enough to my question. Okay? I'm going to show you how to code this. Okay? For those who don't know how to code, don't get scared. This is easy. I'm going to quickly walk you through an example. Ooh, this needs to be much bigger. There's an API here that shouldn't be, of course, but if you are able to copy it in this time, you deserve it. So, congrats for you. So, what I'm going to do is, I'm basically creating an architecture where, on one step, I will convert my text to numbers, okay? And I will save all those numbers in a database. This part is just instantiation, but it's here. So basically, I have a book about Power BI. Do you know what Power BI is? Great. So I have a book of technical documentation about Power BI. And what I'll do is, I will read that Power BI, okay, split it into pages, and then embed, which is the term that we use to transform text into those numbers that I mentioned, text into a meaning. I will embed these documents, okay? And what I do when this is done, what I actually achieve is, okay, it was already here, so even better, but I'll run it again. So what I actually achieve is a certain piece of text. This is the first page, so obviously only said Microsoft Power BI. Do you see all these numbers? This is the way the computer can understand if two things are similar or not. The computer took a bunch of words and transformed it into an idea, right, based on the words around it. And that will now allow me to do what? That will now allow me to ask questions like, how can I do a pie chart in Power BI? And by getting, you can even see that the code is even almost like in English. So if you don't know how to code, it's good. So I asked the question, how can I do a pie chart in Power BI? And what I'm going to do is, I'm going to search in the database for the most similar, the 10 most similar documents. Okay? And if I see the result, I can see in fact that the first document I got was, it included information about pie chart. Of course it included information about other things as well. But that's the good thing about ChatGPT, is that I can give it a whole page with a lot of information, and even if what I want is in just one sentence, it manages, and Fernando will tell us in a bit when it doesn't, but it manages to find out the information that it needs. Okay? And so this will allow me to then build a quite big text, too big for humans, but for ChatGPT is okay. So all these texts are the pieces of information that my system considered somewhat relevant, okay? Taking into account the question. So for now, this is what I've done, okay? And we'll go to the second step. So for now, I've built a system, and as you've seen in 20 lines of code, as you've seen, I have documents. I break it down into, technical term are chunks, okay? I break it down into chunks and I put them all in a database. And parallel to this, whenever I get a new query from the user, I go and look at that database and I end up with, those are the most important chunks for this query, okay? And now comes the second part, which is now I can go to my agent, to my ChatGPT, and create the question like I explained before, which is, instead of asking who is the King of England, instead of asking can I create pie charts in Power BI, I asked it, based on this information that I just retrieved from my database, based on this big piece of text, how do I create charts on Power BI? Okay? And this now allows you to then have your own information, your company's information, being used for ChatGPT to answer. Okay, let's see that last step in Python. So now, what I do is I come here. This one's a bit bigger, but you'll have to trust me. Can you read something? No, it's too small. Too small. Let me try like this, okay? So, what I'm doing here is I'm creating a prompt, as you can see. You are a chatbot designed to help technical answers about a software, etc., etc. Here I include the user question. Technical documentation for the software. Here I include that big piece of text that we found relevant regarding this question, and here just a couple of instructions so that it doesn't ramble on and doesn't talk about religion and politics and all that. And then I tell it, your task, answer directly to the user, point the user into the right direction of the documentation, saying like, yeah, it's found on page 297, okay, and enter in markdown format. This is a technical step so that the output format is a little bit more pretty. Okay, I even give it an answer. This is an example of an answer. Okay, and then code just to call the model. Okay, I'm going to give it the message, and the model will answer with a piece of text. Let's see this happening. So I do this, and takes a bit. Voila. What happened here? I see, okay, it answered the question, how can I do a pie chart in Power BI with this model, GPT-4, and as you can see, I get a somewhat pretty answer, saying, creating a pie chart in Power BI. Like this, like this, like this, sources from pages 270 to 77 from this technical documentation. Okay? So this can be done now with your internal tool. If you work in hotel management, if you work in whatever, you now have the ability to integrate, let's say, your company knowledge onto a question before asking it to ChatGPT, so ChatGPT will ask it based on your question. Okay? Now all this seems too perfect. Now comes the real part. This was a quick search, just for you to understand that this is a completely average, ever-changing industry, okay? Most likely, if you use this small piece of code that I just showed you, most likely it will fail many times, because it's too simple, right? There's a lot of improvements that can be done here, but the truth is that it is a forever changing, it's constantly, we get new ideas and change a little bit the architecture and revalidations and all that. So the truth is that RAG systems, which is these systems that we just talked about, RAG systems have been growing for the past year so that companies can do retrieval-augmented generations based on their internal documents. Okay? And it's basically this. I hope it was clear enough. Do you have any questions? No idea how long it took. Was it okay?
Yeah, good. Any questions for João?
Okay, this is either really good or really bad.
Yeah.
I just came here. I mean, the only question I would have is the chunking is just for basically optimization. There's no actually plausible reason you need to chunk it unless...
The point of chunking is you somehow need to give it a limited, even if it's very, very big, you need to give it a limited amount of information, right? So what would be your suggestion? For example, that book is 410 pages long.
Yeah.
What would be your suggestion? That I give all the 410 pages?
No.
Right? So the chunking process, and that's a great question because there's no time to talk about every detail. The chunking in itself is a whole area, right? What are we doing? Are we providing it a lot of small sentences? Are we providing it pages? How do we make sure that we match a good amount of text with my question, right? So the idea behind the chunking is just this. Maybe in 5 years from now, we're going to laugh at my answer because models can now take 4 million pages and it's nothing. But right now, it is a necessary step.
Hi guys, I'm Fernando and I'm here today to talk about observability of LLM apps. Okay, thanks for the challenge accepted, and I'm here. So I would like to start with something. I worked for many years in machine learning, and 2 years ago I need to reinvent myself because of this new technology. Okay, so I worked 20 years with machine learning, data mining, business intelligence, and my work changed completely. Okay, sorry. So why? Because in the last 2 years, look that the ecosystem changed a lot, and you create a new ecosystem around these LLMs, right? So you have many people work in LLM to create LLM models, to create ways to store proprietary data to using these LLM models, orchestration frameworks, and tools to evaluate these LLM apps. And we'll talk about this part of evaluation, right? I would like to start with this. If you cannot measure, you cannot improve it, right? And I believe, in some sense, we believe that all the outputs of LLM app is true, right? It seems true, right? True, but not. You have many hallucinations, and the way that these models work are not deterministic by nature, right? So we have a randomness how to generate that. So we just generate the next word, as we were talking about that before I start this. So this is very simple in terms of how it works, because we just predict the next word. But this is so very sophisticated in the way that you do that. So we're capable to create very good thing, as you know, right? So, and the outputs are in natural language. So how can we evaluate a natural language, right? Because it's easy to evaluate a number, right? If it's right or not, true or false. But if I provide two different statements, how can I evaluate them? If it's right or not, maybe a little bit, or something is more right than others, right? It depends on the context as well, right? Because in some context maybe it is right, and in another context it will not be. So we have a lot of, how can I say, ambiguity here, because it always will be related to the context, right? So basically, without proper observability, it's hard to understand if the result is good or not. So we start a guessing game. Oh, it's good. It's only my opinion. And the other guy, no, it's not good. It's not answering the things that I would like. But two people saying different things. So it's good or not? Depends. Depends on what? The way that you evaluate that, right? I try to create a very practical talk here. So I will present some concepts while you use the LangSmith. Okay, LangSmith is a tool used to create this observability in the LangChain ecosystem. Okay, but we also have many others. Okay, LangFuse, it's open source, very good. Arise, MLflow, and weighted biases also added these features in this package. Okay, so you have many others. Okay, and you only talk about in 2 years, right? 2 years, new ecosystem. So when I was in San Francisco last June, the main topics talked about LLM area is advanced RAG, LLM as a judge in observability, okay, and fine-tuning. This is the 3 topics, hot topics in our area, okay? And when Cynthia told me that, oh, we need to talk about something interesting in this area, so I believe this observability is a hot topic, is something that most people are figure out that is important, and you need to put this in our solutions, okay? Because if you can analyze, you have some pillars in terms of what is observability. So we have ways to evaluate the outputs. We need to evaluate the traces to identify in the process, in the pipeline, where is the span that we have a problem. Okay. We also need to evaluate different versions of prompt engineering. What it really will work in my context. We don't know. We need to test. We need to test many options. Search and retrieval, and fine-tuning. Okay, so if I add different versions of models, or if I add a different model, fine-tune model, well, maybe in the process we'll have a different output and evaluation. Okay, basically all these tools are organized by project, and in a project we have a collection of traces. So a project is a box where you organize something to analyze everything about that particular context. A trace is a collection of runs that it's created to generate, for example, we'll call a prompt, we will use a LLM, you analyze a retrieval, after this you can call a LLM again, filter the information, and you have the final output. This is a trace, okay? And you have runs, parts of a trace that you can analyze separated, okay? Because sometimes the final result is not good, but the problem maybe could be related in one run particular, okay? So we have a lot of different elements here. I believe all of you you listened chains, LLMs, retrievers, embedding, conversational tools, agents, all of these terms. Okay, this is the building blocks that we use to create these traces. Okay, so let's start with the practical part. Okay, I prepared a few examples here to analyze that. So trace. Okay, let's use here trace. So this is the hello world example. Let me close a few things here. Good. The size is good? Yeah?
Maybe can you please increase just a little?
A little bit?
Thank you. Thank you.
So basically here we have many keys, okay, that we need to use. Link chain API key and link chain project. All of these keys is related to LensBeef, okay, including the endpoint. So all of this is configured here in this env file, okay, and when I call this pipelines, it's many toys examples just to show you how it works. So after I execute this, all of this trace will be recorded here in our project in LensMeet. So we have tutorial 1, and we have the traces here. So if I click in one trace, I can see what is executed in the order of that trace. So many runs about that. And you can debug or evaluate each step of that here. So it enables you to effectively understand what will happen in each call that you do in this context. Okay? So imagine you make many calls, so you can track all of them and analyze this information. Okay? Any doubt about that part? No? Okay. So let's use the joke here. This is the same thing. This is the cell that you configure the entire ecosystem. And here we have a setup where we define from a question tell a joke. Okay? So now perceive two things here. In the first, I use the traceable annotation here in the function. So this defines for link chain that I need to trace this particular function, and this function will be there in the console in the web app. Okay, but if we call directly methods from link chain, we do not need to do that, right? So when you execute, when you execute this, link chain understand that you added that there. Okay, so everything when you use link chain will understand that you use this traceability there. If you create your own pipelines, you can use this at traceable. Okay, for example, here we have a different pipeline where you can execute, and after this configuration, we have here a context. I have a QA prompt and a filter prompt. So basically the idea is to answer the questions that you have in the context, and after this only present the questions that you have a solution. So it's a toy example just to show you the way that you can track all of this information here in Langsmith. So we have this run Q&A pipeline demo. That is the name of our function here. Okay, and you called two different other methods. Here is QA and filter QA. That is executed after that, and you can see everything that happened behind the scenes for us. So this is very useful in terms of what is happening in each part. But you can say, okay, but for simple chains, I can do this. But when you're talking about agents, it's different, right? So if you have an agent working, I'm not explaining everything here, but just I will call an agent to retrieve information for us. Sorry. Here, run on. It will generate a lot of things here, and here in the projects this is agent execution. So agent execution is more complicated, right? Because an agent executes many other tasks that you don't see, but it happens behind the scenes, and sometimes depending on the configuration of this agent, you will happen different things. So many reasonings that this agent will do. Now we can trace this. Okay, so this is very useful to test your LLM before to go to production. Okay. So you can see here trace and traceable and agents, right? Very important part of this code. And so the idea here is to continuously improve if it is good or not. We need to understand what is the best configuration about which model you are using, the sequence of the prompt, the versions of the prompts, the agent we are using, and the tools. And after this, we will have evaluation. So imagine, according to the arrangement of prompts, versions of prompts, agents, different models, which configuration will generate the best evaluation. You need to figure out that, okay? So here basically explain the tracing, and let's talk about evaluation and playground in this scenario, right? First, before to put our LLM in production, we need to evaluate these results. So we have different ways to evaluate in offline evaluation and different ways to evaluate our app in online evaluation. Generally, in the offline evaluation, we have database, we have a ground truth, we have express annotations that will be used to check if our LLM solution for this particular context are good or not. Okay? So if I have a good results here, let's move this to production. But during the production, we need to continuously evaluate our app by different evals and LLM judges that will try to monitor the behavior of our LLM app in production. And you have many things that you need to capture there. Okay? So this the first part of evaluation enables the second part. Okay? So when you're talking about evaluators, we're doing some things that is related to the comparison of data, the ground truth, and reference about the entire criteria that you have in the development time. We also can define different methods to evaluate specific things in the development time. So imagine you would like to have, for example, I will explain in one example in my area. I work in a health tech, so you are analyzing many relationships between doctors and patients during the sessions. So we need to understand if our extractions are effectively getting the point during a session. So imagine I have a pain in my knee. So I need to identify that you have a pain in the knee. This is a body part, and I need to analyze and certify that everything is classified well. Okay, so I can define many ways to evaluate this, create hard-coded methods to evaluate that. Or you also can create many annotations to tuning our prompt. So imagine if I say, I have this session, and I say knee, left knee, and I have another session, left knee, and some expert is annotating this information, I can tune my prompt by using this information and generate many versions of this prompt until I get the information the way that I want. Okay? And you also have LLM as a judge. So you can create LLMs that will be in the pipeline in the process just to evaluate the output of a particular run. So is that okay? The conciseness is good. I have hallucinations here. This is correct or not. So we have many things to analyze in this. So these LLMs are put in the pipeline to analyze this information. Okay? And you also have many different kind of tasks. And according to the task, and the context, we need to define the right evaluators for that. So there is no recipe here. The idea is understanding my context, understand the nature of the question, and the way that I need to evaluate that. It is alchemy in terms of how can we put all these things together. Okay. Before here, we also have the way to create a data set, and this data set is a set of questions and answers. Okay, and the idea here is to evaluate if our LLM app are answering correct or not. So let me change the name of the data set because otherwise I will have an error. And after this I create a prompt that will analyze the questions and to understand if it's good or not. And after this we create an evaluation method and create an application that will organize all this chain together. Okay? And we can run the evaluation. This evaluation, I believe it's almost done. A bit, applies many things here. It's generating. Because it's not data set one. We have many experiments here, and we have different ways to evaluate each one of them. Okay, here I created 3 different evaluators. If the information retrieved is helpful in the end of our process, if you have a hallucination, and the correctness of this process. So, and the numbers here is related to the experiment that I run. So, each one of them is a different configuration, and according to each configuration, you have different performance that you need to figure out. Okay, so you can see here that the experiment 10 is more helpful than others, and you also can see the hallucination is the opposite. So in terms of hallucination, the 16 is the best. Okay, and you have the correctness here in terms of is the best is the 11. So we have good things in these 3 experiments. So now, how can I merge the best practice of each one of them to create a better solution in the end? Why you have different axes here? Because depending on the experiment, we use different types of evaluators. Okay, this is very helpful, guys. This I was told to Cynthia, because I slept at 4 a.m. this night because I'm completing a sprint today, and thank God this exists, because otherwise maybe I'm still programming yet. Okay, but this is very, very helpful. Okay, we also have a way to create playgrounds. So, okay, before to code, let me test some things. So you can choose this data set, and you can start an evaluation about this data set. So all the outputs that will be generated about the model automated, and we start to calculate hallucination and helpful. Okay? So I believe it's still calculating. And just to show while it is calculating, I have these evaluators configured here. All of these 2 are 2 LLMs as a judge. Okay? And these judges evaluate the output of this solution. So we can have different evaluators, and you also can do something very, very good in terms of we can annotate a few things here. What is this? Because this is smaller than this. I do not know it. It just generally is fast. I do not know why it is completing yet. Let me check. A minute. Let me try again. Maybe now it will work. This is the problem of demo in real time. But the idea here is that we have the expected output that we have in our database, and you have the output that the model returned to us. Perceive something here. For example, we have a different evaluator that is related to conciseness. How concise I would like to be, for example. Comparing the expected output and the output, do you believe this is concise or not? Maybe not, right? So this is a different type of evaluator that you can put in this pipeline to evaluate if you are good or not. For example, our problem there in the health tech, in the healthcare area, is to understand the correctness of the extraction. The extraction sometimes need to be done in several steps, where first we capture the first output, and the second output will be related to the one, and after this we check if the selection is good, and the LLM as a judge we evaluate if it's good or not, if you need to rethink. So we have sometimes pipelines built by, I believe, with 20, 25 different runs in a trace. Okay. And you also can have dashboards. Okay. Where you can, for example, manage your costs, understand how many tokens you are using, how many runs you have. So we have a lot of information in terms, for example, in our scenario, each session between a doctor and a patient will have 1 hour when we are talking about an assessment. 1 hour generally costs a few cents, but imagine this is important, the way that we will generate the amount of tokens and how you will manage our costs in terms of this. Okay, so it's easy to have surprises here, but until now, I believe if you are tracking this information. You have information about latency and the number of runs and a lot of things. You can organize better your work. Okay. And here that is deployment annotation queues. I will try again. You also can save many prompts versions as well here. Okay. So the idea,
and then call it from.
Yeah. So imagine you can have several versions of the method of prompts, and also can call them in the playground. Select data sets, and with data sets we can start to evaluate things here. Set one. What is happening here? I really would like to show you this, but it's taking more time than I thought. Let's back to the presentation and wait. Okay, now it's run here. Presentation. So with this, guys, we can optimize and continuously improve our solution. We can avoid hallucinations, inaccuracies, discrimination or bias. We have LLMs adjust that will evaluate discrimination of your results. Okay. We have a evaluator that it's called toxicity. So evaluate if you have toxic information there, and you also can monitor our costs. Okay. The two main takeaways here, guys. This kind of system requires this. This is not something good that I would like to have, or something nice. This is part of the system. Okay? Without this, you are doing something with LLMs. Okay? And if you don't have that, you start to say, people that will say, the answer is not good, and the other will say, no, the answer is good. Who is right? Let's talk about some numbers. These numbers will be defined by the evaluators that we will create. These evaluators must be compatible with our context. Okay, so the observability is something that only will work in your context, because it's about your data, it's about the semantics of your business, and many other things that we need to figure out how to evaluate this. As we said, we have a randomness nature here. We have many possible different outcomes, and it will be in a natural language. How can we evaluate that? So before we were talking about embedding, right? So this is related to this, because what is the best solution in the end of the day? Okay. So the main takeaway that I would like to say to you guys today, and sorry if I rush here, but I really would like to say, this is part of the system, and this will be built according to your context, to be about your context. Okay, so there is no recipe. To be tested, analyzed, and tested again, and try again, and figure out different ways. So sometimes the best way is to review the prompt, because the strategy of the prompt is not good. Other times is related to our agent. Maybe I need to develop my own agent. Sometimes I need to develop a tool. Sometimes it's related to our evaluators and judges. So a lot of things here to be discussed. So this image represents the work that we need to do. So humans evaluate LLMs or AI, and AI evaluating AI. This is what we're talking about. Okay, so I believe this is the conversation that I have for today. Questions?
So is the only way to check for hallucinations by giving the LLM the actual a correct human answer? Or is there any way to automatically detect hallucinations?
You can detect automatic hallucinations with LLM as a judge. So you can create other LLMs to evaluate, prompts to evaluate if it's a hallucination or not.
How do I know that the evaluator is not hallucinating when evaluating the person?
This is a good question. Because of this, we need to measure. And remember when I said maybe this part. Before, we need to prepare and understand your solution in development time. In development time, you have ground truth. So you have many data sets and human annotations in these loopings, where you say the information is a hallucination. An expert can do this. And you also can have an LLM as a judge doing the same job. After this, you can compare both results.
Okay.
So now, my LLM as a judge perform well or not? According to the experts, no. It's still hallucinating. So now we need to figure out different strategies. So after we try to reprocess this many times, now we have a good LLM as a judge that will predict hallucination well. Let's put this in production.
Okay.
So after this, in production, hallucination, and after this we need to make a decision. What are you doing with hallucination? I can create another pipeline to figure out a way to correct information. I will cut the information. No, don't say this. This is another kind of decisions that you can have here in online evaluation. So, most important part, create a background, create a base solution.
And that's always based on a human knowledge that's verified. And
Human knowledge and other AI algorithms to help you. So both of them together will provide you with the information. Nice, now have something good. So I like to see this new world that I need to reinvent myself and all of you 2 years ago. And the main change, I believe it's related to the nature that we need to learn how to work together. Okay? AI will not replace us. It's not talking about that. Okay? The entire human evolution, new technologies will have, and each industrial revolution, the machines will replace our jobs. In some sense it will, but the jobs change. And I believe today our challenge is how we can learn how to work together with this technology, because today I'm more productive than 2 years ago, because I have many tools that help me to work with this. As I said, 4 a.m. today, I have many agents working with me. I was not alone there, okay? And they help me to do my work better than I thought it would be.
Okay.
So this is the main message. We need to work together with these things to help us to create the first version, evaluate the version in production, and continue to improve both. For example, I have a team dedicated in this part. That's something that we put in production in the next 2 months. And you have a team that is concerned how to prepare what we have in production and evaluate what we have in production. So we have one eye in the future and another in the present. So basically this. Another question?
Yeah, you actually talk about creative destruction, Arthur Schumacher. Same thing over the internet, you know? Everybody thought the internet was going to destroy everything, but the only thing is create different jobs. But my question is more like, in your opinion, do you honestly feel, given the complexity of AI, that we can really honestly monitor, completely observe everything?
I believe we have a lot of science fiction in this subject, but I believe we have a completely different world in 2 years. Imagine 2 years ago, before ChatGPT, how you did the thing. I did in a completely different way. Today, I can say I am 50% more productive than I was 2 years ago. So, when they start I remember in the day that they launched ChatGPT, I had another startup that I decided to close after that because it changed the game. So if this technology changed the game, okay, let's learn how to change the game too. So we need to follow the flow. We have science fiction, okay, but we have concrete things that we can do today, and these things are changing the industry completely. We have a completely different world today. Imagine in 2 years. This is the thing that I felt in San Francisco. They are not good because they are genius. They are good because they are there together. They are living a dream because they are doing the things. The problem is there, you know. So I believe we need to learn how to use this, and most important part maybe, how can we help to improve this. This discussion is the way to improve this. One of the papers that you showed here, it's very good. It's a best practice in RAG. So we analyze many things, including about chunks that you asked. So we have several ethics, how to chunk a text. Because it's not just simply chunk a text according to a window, 100 words, 200 words, whatever. Maybe you can split your text according to the meaning of the text, or many other kind of different strategies. So you have many people thinking about this kind of things. Okay, imagine observability. There is a huge field to understand how you can figure out that. This is my line of research. It's how to bring context and semantics for AI. And you have a lot of things to do there. I have no idea what is effectively happening in terms of, there are too many people work on this. It's impossible to follow everything. But I would like to be there together, try something. I do not know if I answered your question.
No, you basically said because of all these people that are investing all this time into one particular subject, and maybe it's more than feasible given the AI complexity that it actually does. It makes sense. Maybe one of these days somebody will solve the problem one way or the other. Find a more effective solution. Find a solution that'll build on the top of another solution. So.
Yeah. And maybe, as you said about fine-tuning, it's a very good technique. But I do not know if I will invest on this, because if in the next month I have the best model in the world, my fine-tune model cannot follow this. So if I would like, where can I invest my time? Specialize in an industry, in a specific area, because if you know effectively an area, you can provide this context for that, and you figure out the ways to tune parts of this pipeline to improve your context, your business.
Your approach is more comprehensive, I really have to say. I mean, the database itself, you have different evaluators, different ways of how they're evaluated, and all of that, the different again, you're mixing each one up and try to find the most optimal solution. Like say you might take a LML as a judge, and then also you maybe do it by comparison, or maybe do it by evaluate it by ground truth. But then again, it's finding the most optimal solution before you actually put your LML in. Whatever you're developing into production. So you're just using a sample of what you're doing. I mean, basic development, you know. If we build out a complex system.
The machine learning is the basis of machine learning was created in this way, right? We create a small set of data, try to create models, and we evaluate that models and put in the production, right?
It's just a framework that's building on top of another thing. It's one small thing building on top of another small thing. Yeah. And after like a complex system. So.
Yeah.